All right, here we are again after a 2-week break for another episode of Programming is Fun, where we develop, or I develop, and you watch me develop a Tetris clone in the browser with the nice programming language Elm, where you cannot make any reassignments to variables. Everything is immutable, and everything is super strictly statically typed. So I try to motivate you or try to sell you on some of the values that come with this strict kind of functional programming, and just try to have some fun while we develop the software. And as I mentioned, I haven't had a look at this for 2 weeks, so I'm curious if I still remember where I left off and still understand my own code, but we'll see about this. So here on the screen you see this dropping T piece. That's basically where we left off last time. We implemented this gravity feature by using the subscription system, so you can quickly revisit that. So the subscriptions are, as you saw, part of the the initial state we have to pass to the Elm runtime environment. In this assignment here, we are assigning this function to this browser element function that we're calling from Elm SDK. And in these subscriptions, we basically can register functions that will send a message at an for us unpredictable time. And in this time, this is the time every function that will send the message, gravity tick, that we pass in here every 1,000 milliseconds. And then we can look what in our update method function from our Elm application that's present in every Elm application. We can see how this gravity tick is handled, and we see like, okay, we calculate a new application state of our model by calling drop current piece, and in drop current piece we see it's also pretty simple. We take the current piece, we take its XY coordinates, destructure them from the current position, and then we assign this to this XY tuple, and then that's just something that I just dropped in here to keep the piece coming from the top continuously, where I said like the next row is like, if it's 0, then we reset the row to be 20 at the very top, otherwise we just decrease it, calculate a new version of the drop piece where we just update the current position to the one with where we increase the row, and then we update our model. So no biggie there, and it was also a very short episode last time, just 30 minutes I think, and I'm going to try to keep it short and sweet today as well. And the next aspect I would like to introduce today is to have the keyboard input, like the left and right arrow, to actually move the piece left and right while it's dropping. So that's what I'm going to look into tonight. Okay, cool. So obviously the entry, or one of it always depends if you want to develop top down or bottom up, but for keyboard input I say the most exciting question is how do we get the keyboard input in the first place. And I think there is a method. I'm always showing how I'm googling my own hints. Basically I do some of the stuff I know from the top of my head, but I'm not using Elm in my day-to-day life, so it's only for my fun project. So I still have to look up some of those basic functions over and over. And I think there's something like on key down. Wow. And we see there's a hit that I've visited before, so there's a good chance this is what I want. And what does it say here on the top? In JavaScript, information about the root of an HTML document is blah, 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 blah. This module lets you create event listener on those objects. Mouse, keyboard, yeah, that looks good. Keyboard is interesting. On key press, on key down. Subscribe to get key. This can be useful for creating games. I think this is a pretty good start. So, and we see by the signature, we get a subscription from this. So this gives us already an indication on this, on how this is supposed to be used. But let's just make sure we can actually import this. This is part of Elm browser, which I believe is part of the core library, but we'll see about this. So first I will try to import this and drop this here. Exposing, because I only want to use this function, I will expose this explicitly. On mouse down, that looks great. The code formatter from Elm also arranges the imports alphabetically, so that's why it flipped up here on the top. So that's why also I don't bother really where I insert new import statement, because I know the code formatter will rearrange it anyway. Let's check our page. Oh, and it's still running, so that means like I have this build script in the background, which basically watches my the source file, and if it changes, it will recompile it. And if something is broken, I will can just quickly show this. Remove the N here, so I have a broken input, and then we see we get actually the compile error in our browser window, so that's very helpful. So let's fix this again. So that means that it's compiling correctly at least. So that's a good thing, I guess. So let's get back to the documentation. We said on key down is the one where it says like it's good, useful for creating games. And then there's like, check out this advice to learn more about decoding key codes. So it's more complicated than it should be. So that's always scary, but let's just have a look. Which key processed, and it goes into detail why it's more complicated. I will not read this out. I leave this to you for you to read up. I will put a link to that in the show notes. But we see basically what it means. It's like we get a JSON object from JavaScript, and that's why we have to be able to subscribe to that message, we have to give it a decoder that will decode this message. So let's first go to our subscriptions and try to jam in the subscription there. And there's actually it's a good opportunity to talk about how we do this, because we see we are already returning a subscription, so we cannot, like, we can write our, what is it, on key down here, on key down, is that the correct case? Yeah. And we know we have to call some decoder here, so I will just put this in here. But the question is like, how do we do this? Like we can obviously put this into an array, maybe like, because it's only two, we can actually put them on the same line. So, but now it will obviously complain, because we're not returning a subscription, but we're returning a list of subscription. Oh, actually it's complaining it cannot find this variable. So what did I import? On mouse down. Oh yeah, that's bullshit. So let's just say on what did I say? Key down. So now, yeah, it complains about the decoder variable. That's also fine. Well, then maybe I fix my. Well, yeah, we'll just go down that route. Because I also want to show like the compiler is a very reasonable thing to listen to, and it helps us to discover what we need to do. So it says it cannot find a decoder variable. So key decoder string. Okay. And we're not entirely sure. Like, I haven't talked about how JSON decoding works, and it has a bit steeper learning curve than it has in, let's say, in Ruby, where you just get a dictionary or a hash, and then you can just traverse this, because we want to explicit about the types that we read from JSON. So we'll see a bit of this, but I think looking at JSON decoding is worth a separate episode for its sake of its complexity. But let's just do something here with that. Or let's just we just copy this whole thing. It's always a good Stack Overflow approach to just the simplest approach sounds great for us, right? So where it's called key decoder, so let's stick with that. Key decoder. On key down, key decoder. Okay, what's happening next? Import JSON. Okay. Oh, and it's again wonderful example for the great error messages, because Elm is detecting that we're trying to import a package that we haven't declared in our dependencies, and it gives us a very constructive hint by telling maybe you want the JSON decode module defined. So running install Elm JSON should make it available. So lazy developer that I am, I'm just going to put it in here. It says, oh, I know it already in my indirect dependencies. Should I move it to the direct dependencies? Yes, please. Cool. Let's build again, and we already see some error messages here. And it says something is off with the body of subscription. The body is a list of type list, but the annotation on subscription says it should be just a subscription message. So I don't know the design decision behind the fact that subscription expects just one subscription message, but basically the subscription type comes with its own method to create lists of subs or combine subscriptions, and it's called batch. And I don't know if this is actually mentioned. Like, when I had to use it for the first time, I had a bit of a hard time finding it. But yeah, I mean, there's elmprogramming.com. Yeah, we see there's no mention of this, at least not in the top hits to the Elm Lang package, Elm Lang documentation or guide directly. So let's see what it does. Oh, we can actually use this search sub badge, and you see it takes a list of subscriptions and makes it a single subscription. So from the signature, it looks directly what we need, and it says when you need to subscribe to multiple things, you can create a batch of subscriptions. So actually less exciting than it is or sounds. We will just call sub batch. And now I will actually do I'm so used to being arrays broken down, even if they only have 2 elements. So we'll do this for now. And what does it say now? The second element, this on key down call produces sub string, but all sub message. Okay. So because and it should be sub message, right? Because it says here we want sub message. So the key decoder should be message. So now obviously that will not match anymore with this expression, because this expression says basically from the JSON that we are passing, take the field key and expect its value to be a string. and that's what we are returning. So what will we do? I think I will, for the time being, I will just remove this, and we can have a quick look at how to get back here. Elm, JSON, decode, and let's just say I want to always, like, we want to decode a message that I already expressed, and the succeed method is the simplest way to provide such a decoder. This just takes a value of type A and creates a decoder from that, for that type. So we can just say decode succeed, and what message do we want to send is the obvious next question here, and I will say we create a new key pressed or key down message. So we go to our definition of our, maybe here, of our messages, type message, and we say key down. And I deliberately skip over adding any details to this because I want to make small compiling steps. So let's see if it's not happy. If it's not compiling yet, and that's correct because we have missed to update our update function where we actually handle a message of that type. So that's what we are going to do next. Update. Let's find it. It's here. And we are going just to copy this. And we are going to say, what did I say? Key down. And we're going to continue to do nothing. That's okay. But at least it's compiling again. So let's just, before we get into handling the actual keys, I would say we implement the function to move the piece left or right, and move piece, translate piece. Let's just start with move piece. It's easy to refactor. I'll rename it if we want to change that name later on. So we say in move piece, we pass in the current model. I'll do a signature here. What I'm planning to do, it takes the old model and returns a new model. That's pretty straightforward. Model, and we'll probably have to do some local calculations. So I'm already creating a let block here, and I know what did we call this? Current piece. I see. New piece. Let's do it this way. And like we can already, like I still have the drop current piece function from last episode here, and we can actually take a lot of inspiration from that. So actually I'm going to steal this expression here, how we grab the current piece. Whoops, that was not it. How we grab the current piece from the model. And I'm going to grab this destructuring as well. XY, current position, and then, oh yeah, drop piece makes also a good candidate. So we call it moved piece. It takes current piece, and Y is going to stay the same, and X, like that. We just hard code the movement to the left for now. So when we receive the key down message, we call the move piece, which calculates a new version of our application state model where the current piece is moved one column to the left. So, and let's see where we use the key down message again, like the key down message is parsed from a JSON object that gets sent to the application, or we have a subscription that gets called every time a key down event and from JavaScript is triggered, which will call this decoder, which in return generates the message key down for us. So what I would expect is if it compiles, that we first have to check. Let's see if that holds. It does not, because I called new piece moved piece. So let's fix that quickly. Now it's compiling again. So the behavior I'm expecting is that no matter what key I press, the piece moves one portion to the left. So I can just, and it works. It works to an extent where I actually can move the piece out of the board, because we don't have any board bounce checking, and if I just reload, then it starts over again. And it's really, even if I press the control button to switch between my screens, like this is triggered. So obviously we have to put in some checking, like bounce checking, and also registering which key was actually pressed. So that's the latter is the step that we're going to do next. So this is, as I said, like currently our JSON gets parsed into a constant message, the key down message. Or let's actually start by parameterizing the key down message itself, because, and like the naive solution would to be like, okay, we just put a string here and we just put this into this field, whatever string is in this JSON object that we get from the JavaScript event. But that's not how we do things in the strictly functional world. Like we barely use these primitive types for important stuff. Every time something has a meaning, we try to really create a type for this. So, and maybe we just call it key. So obviously we have to come up with a type declaration for this, and like it will ultimately be something like left key, right, like left arrow, right arrow, and so on. But I continue to be very minimalist about our small steps. So I will say, like, just to confirm our current behavior, I will only say we have a left arrow here. So now we made some small changes which expressed our intent. So it's a good time again to just save this, and let's see where the compiler says we should look at next. 189 key down variant needs one argument. So let's see where that is. Okay, so this has a parameter key now, which is correct. And we probably also want to, let's not get ahead of ourselves. And just make that next change. And now it says something is off with the body of the key decoder definition. Blah, 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 blah. This succeed call produces decoder to a function of from key to message, but it should be just a plain message. So let's see where that is. 240, it's here. And as I said, like this always successful decoding into this one constant expression. So that's not what we want. We want rather this expression that was there before again. So, whoops. Let's bring back that to life. We'll stash this expression here. So now let's see what it says. So now this produces a decoder string. So that's also not really what we want. And I think now is a good time to consult this example that was referenced from the documentation again. Where we see, okay, they also use this function that we are using, or this expression where they decode the key field into a string object. But then there's this decode map to key, and then to key. Okay. String uncons. I'm not really sure what this does. But I mean, the function says to key takes a string and returns a key. So we can just steal the signature for now. That's a good start. To key takes a string and returns a key. So we only have one key for now anyway. So we'll just say this is always a left arrow, and then we will also steal this part of the expression and see if it at least compiles now again. It does not. Key character. Okay, and in 250 it says the field value is string. Where's 240? Because we omitted the parenthesis, and it's not good, of course. That looks a bit more tame. This map called produce la 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 la. That's also true because we produce a key and not a message. So we actually should say this is, what did we call it? Key down, left arrow. Cool. And we're compiling again, and we are still moving whatever to the left, whatever key I strike. Okay, so but now we have something we can debug on, and I don't know if I've shown this before. One of the definitely most used functions of JavaScript in my JavaScript past is the console log function, and Elm has something similar, and it looks a bit weird. I'm just going to write it out and then explain it afterwards. Debug.log to key string. So because we don't have side effects in any of our functions, all of our functions are pure. Every expression has to be, or every function call has to be assigned to something, because otherwise it doesn't make sense. And that's why Elm insists on this format. But we just assign and we don't in the real life, we don't obviously we don't expect the debug function to log function to return anything. So we just assign its result to the underscore variable, which the convention says like basically it's not used. And then we have two parameters to log. The first one is string, which is basically just to mark which log statement we are referring to. And the second parameter can be any object, and Elm will take care of serializing or stringifying it to print it on the console. So let's save this, open our developer tools in Chrome. I'll just quickly flip this to the side and open the JavaScript console, clear all confusing errors for now, or messages. It's not really errors. And now I will press let's say the X key. Whoa, that seems straightforward. So I'm curious what it would say if I press the left arrow. It says arrow left. Isn't that wonderful? Okay, cool. So that gives us a bit of an indication how we are to improve our declaration here. So we can basically say case string of what was it? Arrow left. Okay. That's basically what we want, right? Like, it's straightforward to add the right variant, but let's for now just do that. And the compiler's not happy. Why is it not happy? This case does not have all branches. That's true. Missing possibilities include, yeah, so that's also maybe a bit confusing if you haven't seen this before, but it basically means like it tries to show us the smallest possible pattern that we don't handle in this case statement, and the underscore is the placeholder for everything else. And because for our algebraic data types, it's really easy to enumerate the missing cases, but for a string that's obviously not so easy because it doesn't know what or the set of potential strings is just very, very large, so it just gives us this default pattern. And in fact, that's exactly what we are going to do, because we want to have basically this catch-all thing that will be handled for all the other keys that we're not interested in. So the question is, what do we do in this case? And I think we just want to, we have to emit a message. That's the only disadvantage. So I think I will just implement a no-op message. Open our type definition for our message type again, and add this type type message. So here we say no op, and we go to the update function, which is just below. Copy the right case, which already doesn't know. And I think I will invest a few minutes to remove this left-right stuff, which is still from my boilerplate code and which is becoming a bit confusing since we're doing actually left-right stuff. So I will finish this one task and then I will quickly clean this up. Here we say no op, and we just do the no op and return the old model and no command. So we'll save this and it's happy again. So that's good. And now I can actually, if I press, I can show it again on the camera. If I press, space or any key, it does nothing. And when I press the left key, it moves to the left. Isn't that awesome? So I would call this a partial success, at least for tonight's mission. But yeah, as I said, before I move on, I will remove these weird, confusing left-right messages. So for you who haven't been around in the first episode, I showed this boilerplate code, boilerplate. That's not even just code. It's like a whole folder of files, which also contains our build script that I've continuously, which is just a bash script, which is continuously calling the Elm compiler once one of our source files changes. And this has just a left-right counter example basically. So I will just remove those two messages because I know they have nothing to do with our Tetris. And then again, showing it's a great opportunity to showcase the strength of this strongly typed language, because now it will tell us all the other places in our program that we have to touch where we have to remove the remains of those two messages. So 178. Let's jump right there. That was not this one. So yeah, obviously this one has to go, and I have a strong hunch this has also to go. So we just remove those, and actually that was all the remains that were there from our boilerplate example, or at least these two messages. So this is great. I can, with the left arrow key, I can move out the piece. And the satisfying follow-up task to all the hard work we have done so far is obviously to add the arrow right key. So I have here my type definition for the key type, and I'm going to duplicate this line, replace this with a pipe, and change this to right arrow. Yeah, it's going to be interesting. Yeah, I'm just going to, again, I'm very dogmatic tonight. I'm going to follow the compiler, and it does not really tell me something that is also telling me something, which is that I'm not handling this type anywhere yet. But of course we can at least go to a place where we use left arrow to see what has to be. Oh yeah, actually I can first remove my debug statement here, because I have again a strong hunch that this is called arrow right. So replace this, right arrow. And let's see what the compiler says. Compiler's happy. I'm pressing the right arrow and it moves still to the left. So that's a bit disappointing. So let's revisit our move piece function. There we go. Actually, let me close this here. Move piece. Bring this to the top. So, and like, look, just looking at the signature of this function, it becomes obvious why moving right or by controlling the direction cannot work, because we're only passing in the old model. We're not even passing in which key we have pressed. So that's pretty useless. So definitely something we want to add here is the key that was pressed. So let's add this. And yeah, we can actually move this out into a new local expression where we say new position equals case key, key off, left arrow, and duplicate this for the right arrow, and for left arrow we subtract one, and for right we add one. And then we assign the new position to the position for the move piece. Let's see. Syntax checker is happy. Compiler is not happy. I cannot find a new position variable. Yeah, that's correct. This is called position. Okay, cool. But compiler is still unhappy. It says in line 180, something is off. The second branch of a tuple, blah blah blah, is of type from model to model, but it just wants a model. Move piece model 180. Let's look at this. So again, we just added a parameter to our move piece function. So let's see what we call it, and we see it expects 2 parameters and we only pass in 1. But luckily, we already declared, or we already know which key was pressed, so it's just a matter of adding this to the call. Let's see. Compiler is happy. Pressing the left arrow, goes to the left. Pressing the right arrow, goes to the right. Oh my gee. So, that's pretty good. What does the time say? Okay, we're at 38 minutes. So I think that makes a nice small package for tonight's episode. As always, I'm going to write up a few show notes for this episode where I'm maybe go into a bit into detail about this, about the parsing of this JSON. As I said, it's a whole topic, but I glossed over it a lot tonight, so I take that opportunity to go a bit into detail, and there are lots of great introduction and articles already online that I will link to as well. And yeah, I don't know, next week, like there are 2 things that stand out to me that we could look into next week directly. It's either collision detection, make sure our tile does not actually fall through the floor, or we could implement rotation. So I currently tend to want to solve the collision piece first, but if you want to find out, make sure to tune in next week. Thanks for staying with me tonight. Bye bye.